Hello students, in this video we are going to discuss chapter number 14, electric current and its effects. Okay, let's begin. This is in this picture we see the setup to check how steady your hand is. Here we see a cell and a clip, wire, some pins, bulb and a key. Let's see how this bulb is glowing, and before that we will see this table. This is the electric cell, and the symbol of the electric cell is this one with a longer line and a shorter line. The longer line represents the positive terminal of the cell, and the smaller one represents the negative terminal of the cell. This is the electric bulb, and this is the symbol of the electric bulb. This is the switch which is in on position. Here we will see two dots joining with a line which represent in on position, and this is the off position of switch. Here there will be a gap between these two dots which represent the switch is in off position. It is a battery. Battery is a connection of two or more cells. This is the symbol of the battery. This is one of the cell, and this is the another cell, and the dots between this represent that we can put as many cells as required. And this is the wire. We will represent the wire with a line like this. So we have to keep in mind that the combination of two or more cells is called a battery. Okay, then let's see. This is the combination of two cells which makes a battery, and this is the combination of four cells which makes the battery. But in most of the instruments we don't see such a combination of battery that is in a straight line. We see in this manner like this. So when we make batteries, the negative terminal of the cell will touch with the positive terminal of another cell, and so on like this up to the last end. But when we arrange the cells like this is the negative terminal and this is the positive terminal. So the positive terminal of the cell will connect to the negative terminal of the another cell with the help of a wire, and then the positive terminal will connect with another wire like this and become a battery. Or like this we can revert the cell like this, which is the negative terminal at the upper portion and the positive terminal at the lower portion. So the positive terminal will connect with the negative terminal of another cell, and here also the same thing happen. The battery is formed. This is the cell holder which we commonly see in the device like remote control or doors or any other electronic devices. We see this is a battery, and this is the battery used in tractors, trucks, inverters, etc. Here also the same thing happened, that is this battery is made up of many cells combining in a similar way that we have discussed just now. you see these green dots are the terminals of the different cells. The positive terminal of one cell will connect to the negative terminal of another cell, and then from the positive terminal of the second cell to the negative terminal of another cell, and so on like this. At last we will get the negative terminal output and the positive terminal output, and we can use the electric current from that battery. Let's see another activity 14.1. In this activity we will set up a circuit like this. Here we see a cell, a switch made up of a pin, wire, and a bulb. Here the bulb is glowing. The bulb is glowing because the circuit is complete. As we see, there is no gap between the wires and the bulb and the cell, and the switch is also in on mode. In order to represent this electric circuit in a circuit diagram, we can draw like this. This is the representation of the bulb, and this is the symbol of the cell, and this is the switch in on position. The current from the positive terminal of the cell will flow in this direction and will pass through the filament of the bulb, and then will reach here, and the switch is on, so it will again pass through the switch and will reach the negative terminal of the cell, and the circuit is completed, so the bulb is glowing. And in another circuit diagram here, there is a gap between these dots, that is the switch is in off position, so there is an incomplete circuit here, so the bulb is not glowing. And there is a caution that we have not to touch the lighted electric bulb connected to the mains. It is very hot and your hand may get burned. Do not experiment with the electric supply from the mains or a generator or an inverter. You may get an electric shock which may be dangerous. Use only electric cells for all the activities suggested here. So we have to keep in mind that whenever we want to do any experiment, we have to do only with cells, and we have not to use the electric supply from the main that we use in our house, that comes from the electricity department. Inside the bulb we see a little wire. This wire is known as the filament, and if the filament of this bulb is broken, then the circuit will be incomplete, and then the bulb will not glow. We have to keep in mind that if the bulb is not glowing, then we have to check whether the filament is broken or not. And the next topic is the heating effect of electric current. For this activity, we will take an electric cell, a bulb, a switch, and a connecting wires, and we will make an electric circuit as shown in the figure 14.9, that is here. And after making an arrangement like this, when we touch the wire, we will feel little hot, and for this also we will not to touch the wire for a long time, since it may burn our skin. The wire here is heated because of the electric current. This effect is known as the heating effect of electric current. Let's see another activity 14.3. For this activity, we will take a nichrome wire in some part of the circuit and the switch and the battery or the cell. When the switch is in on position, the nichrome wire will become hot. This becoming the nichrome wire hot is due to the heating effect of electric current. When we see this heater, there is a coil of wire. This coil of wire is called the element, which is the heating part of this device. When a current is passed through this coil, it will heat up due to the heating effect of the electric current and will produce a heat, and with the help of that heat we can cook our food or any other things like water to boil. And in other appliances, electric appliances such as immersion heater, hot plates, irons, geysers, electric kettles, hair dryers also have such kind of elements inside them, which we do not see the heating part easily. This heating part is inside the electric appliances. When the current passes through the appliances, the coil or the element will heat up and it will produce heat, and we can use accordingly. Here in this picture we see that the bulb is glowing. Here, when the bulb is glowing, heat is also produced due to the heating effect of the electric current. So we have not to touch the glowing bulb, which may burn our skin also. The amount of heat produced in a wire depends on its material, length and thickness. Thus, for different requirements, the wires of different materials and different lengths and thickness are used. The electric bulb which we see here consume a lot of energy, electric energy. So instead of this type of filament bulb, we use the tube light and compact fluorescent lamps. But nowadays, instead of these tube light and compact fluorescent lamps, we use the LED, which is the light emitting diode, which consume less amount of electricity, so that we can save electricity. And when we use any electric appliances, we have to buy or use only appliances which have a standard mark on products called ISI marks, which is an assurance of conformity to the specifications given on the products. When the current is flowing inside a circuit, the wire becomes hot. So with the help of this concept, we can make a fuse. With the help of this fuse, we can save many devices or instruments which we use inside the building, because when there is a huge current inside the house, most of the appliances will fuse. So in order to save the appliances, we use a small piece of wire which is known as a fuse. This fuse is made up of element which is a low melting point. When a high current passes through the fuse, it will melt very fast and it will break the circuit. That is, the electric current will not go further inside the house and will save the devices that use inside the houses. And this is another type of fuse used in electric appliances. Here also the same thing happen. When there is a high current, the fuse will melt and it will break the circuit and it will save the electric appliances. Nowadays we see a device called miniature circuit breaker like this. These are also a switches which automatically turn off when current in a circuit exceeds the safe limit. That is, if the current is more, then this switch will automatically off, and we can put it on when once again the current is in safe condition. And there is a caution: we have always used proper fuses which have been specified for particular applications carrying ISI mark. We have never not to use just any wire or strip of metal in place of a fuse. If we use such type of normal wire or any metal instead of a proper fuse, then it will damage the electric circuit and the possible fire will occur. So we have to use the proper fuse. The next topic is the magnetic effect of electric current. For this activity, we will take an iron nail, a switch and a battery or a cell. The wire will be wounded on the iron nail and it will complete the circuit like this. When we put some pieces of iron near this iron nail, it will attract the pieces of iron. When we switch in the off position, then it will not attract the pieces of iron. Here, when the circuit is in close, the iron nail becomes just like the magnet. So such coils are known as the electromagnets. This is the magnetic effect of electric current. That is, we have to remember that when there is an electric current, there is always accompanied with a magnetic effect. We can increase the power of this electromagnet by increasing the number of coils or by increasing the number of cells. We can increase the power of this electromagnet by increasing the number of coils or by increasing the number of cells. In order to see the effect of electric current, let's see this activity. For this activity, we will take an electric bulb, switch, a cell, and a magnetic compass. Here the wire will be wounded like this, and we will make an arrangement like this. And when we switch it on, the bulb is glowing, and inside this coil we will put a magnetic compass, and the magnetic compass will map the direction in a proper way, that is it's magnetic, that is it shows its direction north south direction. When the switch is in on position, the magnetic compass deflect, which means that there is an there is an magnetic effect here. So with that magnetic effect from the wire, it deflects the needle of the compass. This experiment proves that the coil of the wire has a magnetic effect of electric current. Let's see the working principle of an electric bell. The electric bell here have a battery, and there is a gong, and there is a coil. When this electric bell is in switch on, the gong starts hammering, which produce sounds. Let's see how the electric bell works. It consists of a coil of wire wound on an iron piece. The coil acts as an electromagnet. An iron strip with a hammer at one end is kept close to the electromagnet. There is a contact screw near the iron strip. When the iron strip is in contact with the screw, the current flows through the coil, which becomes an electromagnet. It then pulls the iron strip. In the process, the hammer at the end of the strip strikes the gong of the bell to produce a sound. However, when the electromagnet pulls the iron strip, it also breaks the circuit. The current through the coil stops flowing. The coil is no longer an electromagnet. It no longer attracts the iron strip, and the iron strip will come back to its original position and will touch the contact screw again. This completes the circuit again. The current flows in the circuit, and the hammer strikes and the gong again. This process continued in quick succession. The hammer strikes the gong every time the circuit is completed. This cycle continues, and the sound is produced in the electric bell. Let's see what we have learned in this chapter. It is convenient to represent electric components by symbols. Using these, an electric circuit can be represented by a circuit diagram. When an electric circuit flows through a wire, the wire gets heated. It is the heating effect of current. This effect has many applications. Wires made from some special materials melt quickly and break when large electric currents are passed through them. These materials are used for making electric fuses, which prevent fires and damage to electric appliances. When an electric current flows through a wire, it behaves like a magnet. A current-carrying coil of an insulated wire wrapped around a piece of iron is called an electromagnet. Electromagnets are used in many devices. Here it comes the end of the chapter. Thank you all.